Today, we'll learn how to compute the integral of 1 over x squared minus 9 using partial fraction decomposition. Our goal here is to decompose the given function into simpler fractions that we can integrate individually. Let's start by considering the integrand, which is 1 over x squared minus 9. The first step in partial fraction decomposition is to factor the denominator of the fraction if it can be factored. And x squared minus 9 is a difference of squares that we can rewrite as x plus 3 times x minus 3. Next, we'll set up the equation for partial fractions. We want to express 1 over x plus 3 times x minus 3 as the sum of two fractions, a over x plus 3 plus b over x minus 3. Our task is to find these values of a and b that satisfy this equation for all x. To eliminate the denominators, we multiply both sides by the original denominator. X plus 3 times x minus 3 leads to the equation that 1 equals a times x minus 3 plus b times x plus 3. Now we will solve for a and b. Let's begin by expanding both sides of the equation. The right-hand side becomes x minus 3a plus bx plus 3b. Next, group by like terms. This yields a plus b times x plus 3b minus 3a equals 1. Now, notice that the coefficients of like terms must equal. That is why a plus b equals 0 and 3b minus 3a equal 1. Let's solve these linear equations to find the values of a and b. If we solve the first equation, we obtain b equals negative a. Substitute b equals negative a into the second equation. 3 times negative a minus 3a equals 1. So 3a plus 3a equals 1. If we solve, we obtain a equals negative 1/6, so b is simply positive 1/6. Now, return to the partial fraction decomposition and write the expression with the values of a and b we have found. As a result, we have that original integral is equal to the integral of negative 1/6 over x plus 3 plus 1/6 over x minus 3 dx. Now we integrate each term separately. For the first term, the integral of negative 1/6 times 1 over x plus 3 dx is negative 1/6 times the natural logarithm of the absolute value of x plus 3 plus the constant of integration. The second integral is similar. 1/6 times 1 over x minus 3 dx is 1/6 times the natural logarithm of the absolute value of x minus 3, putting it all together. So, integrating 1 over x squared minus 9, dx results in the expression we see here. And remember, this expression is valid up to a constant of integration.